I can give an analogy to this because in statistics we say this rebound effect, right? Where
Hmm.
let's say you are developing on certain technology or a product to suffice or with a certain intended purpose to serve, but
Hmm.
with the availability increases as the demand is also increasing, we assume that the other demand or maybe the other alternative will also be increased, rather
Hmm.
only supply for this. But what actually happens is because the availability is more, the demand inherently also increases.
Yeah.
So I feel that it is also similar to minerals, right? Minerals,
Mm.
elements, because since you gave an example already of 16 years, so let's assume 16 years is a very long time, and for any R&D engineer or a process engineer, it will take at least 5 years to make any technology commercial, right? By the
Mm.
time it
Mm.
is incubated, worked on, and maybe
Hmm.
then comes into the final stage. So how do we understand this, Thomas, when we look at this from supply chain and from economy part? Can you help us see this new view where we see, okay, if I am an investor, how
Mm.
do, from my perspective, what is my understanding to understand these nuances of this
Yeah. So before I answer this, let me go back to that analogy you found with the
rebound effect?
growing consumption. Yeah.
Yeah.
There's also Jevons effect, 19th century economist who found that energy efficiency leads to more energy demand because
Exactly,
prices
right.
fall and
You got
consumption grows and so
you
on.
gave
Exactly. So that's
I
exactly what
think
it is. Yeah.
more apt example for
Yeah.
this. Yeah.
So that's exactly what it is. Now, where you're an investor, you have to look at a couple of different dimensions, right? What's your capacity to invest? What's your willingness to invest within a certain time horizon?
Mm-hmm.
Giving that there is an opportunity cost because there are other opportunities as well, right? So
Yeah.
these are those different levers. Mining doesn't stack very well on that. You mentioned a lab, working for 5 years. Yeah, often, big breakthroughs can be brought from there to a pilot plant, from a pilot plant to a demonstration plant, and from then to the sort of for early commercial development for everything that does not require all that much geological work. Once you actually need geological work, once you need land access, there are usually
Mm-hmm.
people there. Maybe there is a forest.
Yeah.
Maybe there is some
Mm.
animal. Maybe there is, some dispute over who it belongs to. Maybe there's something that belongs underground or some historical, population left something that's important for archaeology. Whatever. It
Mm-hmm.
takes so much longer. And unfortunately, I'll give you an example from the US perspective here. Our capital market is actually not geared up for that level of patience because you need patient risk equity. And that's why
Okay.
most of these companies actually are listed either in Australia in the public market or in Canada in the public market, which is more geared towards this. In Canada, retail investors actually tax incentivized to invest in those non-cash generating companies that are developing these, let's say, instead of the lab, it's in the ground, developing these projects over such a long period of time because they don't
Mm-hmm.
generate any cash. So in a way, an investor is subsidizing this, and it often gets diluted on its equity. So not an extremely attractive value proposition if you can invest in AI today and it doubles tomorrow. At least that's what people believe,
Yeah.
right? So
I mean, why would
so
you go for this, which is risk
so,
having more?
so the question is, how do you actually match the reality of the actual industry, so physical industry such as mining and metallurgy, with the products in the capital market? And the counterexample that actually worked really well here, so not ideal for the green story, but it worked really well in the US, is fracking. So fracking in oil and gas came with a technological breakthrough in 1997 and
Mm-hmm.
accelerated the process. So much so that capital market was ready, especially on the private side, to assume high capital depletion, very large flexibility of those companies because the footprint is small. So you can either pay the dividends or just drill the next well next door, depending on the preferences of the investors, and short duration. You don't wait 16 years. You wait maybe 2 years, right? And so,
Mm-hmm.
and the capital market just enjoy that. Right now in the US, there is no good product to incentivize something that would last 16 years. And maybe there are ways to compress these timelines. Permitting reform would help. Legal reform would help. Maybe a better oversight of federal lands. Just to accelerate the process. Technology should help, but it's been slow, I have to say, in terms of like processing the knowledge. I mean, AI, of course, helps the big data and so on, but you still need to physically drill a lot of holes
Yeah.
around to understand what's there. So there is no there is no ideal capital uh, product that could consolidate massive allocator funds to to smoothen this whole process in mining right now. It will change because in this fourth industrial revolution, critical minerals could be exactly that bottleneck, right? Not so much human capital itself, as AI is taking the jobs away from us anyway, but that 3D thing from which the widget is made is still limited, right? It's still limited in supply, and so much more capital has to go into it if this is the economic factor that's limiting not only green technology revolution but also other technological advances.
So, who are the real gatekeepers of change then? Governments, corporations, consumers, or someone else?
All of them together, all of them together. There's also one aspect which unfortunately we have to take into account as well in 2020s, as opposed to our life before in the globalized world, and that's the level of conflict.
Mm-hmm.
Because that means that the flows of different materials, as we see now as well, are disrupted. And as they're disrupted, what's happening in the Persian Gulf does have an impact on the mining industry as well. It affects aluminum directly. It affects sulfur, therefore sulfuric acid, which is important for processing of nickel, copper, uranium, and other things. It affects helium, which is an important gas also for certain processing. So we are eminently dependent on free flows. They are no longer free for a variety of reasons. What does it mean? It means that part of the criticality of the materials depends on the compressed timelines to obtain the material, no longer just to mine. Let's say it's being mined, it's being processed, but can you quickly get it? And so, because just in time that the Japanese invented in the 1980s is no longer really the prevailing mode of operating, if you have that level of risk of disruptions, of course, building inventories is. And to build inventories, on your balance sheet as a corporate, it's an expensive proposition. Especially some of these materials actually have to be preserved in quite sophisticated stockpiles, right? It's not just that you accumulate something, on a pile. They might need vacuum, they might need certain temperature or humidity, or sometimes the corrode or pulverized or something. So it's sometimes complicated and costly. So imagine the cost of holding big inventory rather than in the past, okay, I'm going to just push the button and China will send it to me. Well, we're no longer in this world, especially for those critical minerals that may be sharing their application between green energy and dual use, meaning military applications. Because this is where there's a lot of leverage and a lot of weaponization. Okay, I'm not going to sell it to you because your producer will sell it to aircraft maker or missile producer or something like that, and that generates also
So,
more. It is more sand
yeah.
in these wheels.
Yeah. And if we look at it like from this perspective, right, where all in all, the mineral, we started the conversation saying that these are all finite materials. A mine is bound to end,
Mm-hmm,
whether it is 16 years, 20 years, or so on and so forth, it is bound to end. So
mm-hmm,
how, when we look at from this finite element, and also we have this, let's say, in terms of how this transportation of minerals can be done and how quickly can it be accessed, so this brings to me, like, I feel now I would like to know more about this. So if you had to pick one lever, let's say policy,
mm-hmm,
technology,
mm-hmm,
culture, and finance,
mm-hmm.
which system moves faster?
Yeah, I because in different countries we have different geology, so we have different
Mm.
endowment, and different
Yeah.
countries have also very different levels of excellence, right? So, say Japan or Taiwan or Korea or India are better at something than say France or Germany or Spain, right? And so it does make sense to have
Mm-hmm.
actually a global system. Let's say China or Russia don't want to participate in it. It's their problem. But if the rest of the world could actually develop a system that works, I mean, the US has not been particularly helpful in this recently, honestly, but at least it signed some bilateral deals. So at least I think the government here understood that it needs Australia, it needs Japan, it needs Malaysia, and so on. So there is sort of burgeoning sense that you cannot solve it by yourself. Once you do this, unfortunately, the plumbing of that system would be complex because if you want capital to flow freely between those different opportunities in the free world, then you probably need to also adjust the tax treaties between those countries. So there is a lot of work to do, right? Let's say
Mm-hmm.
if a U.S. investor would like to reduce the cost of equity of a Canadian company that will produce graphite for Indian batteries, then right now the US investor gets no tax incentive to do this because it's a Canadian company, not a US company, right? And so there's a lot of work that needs to be done. I'm not sure in the current climate, international climate, it's so easy to pull off, but I'm not losing my hope yet. Definitely, we need to
Yeah.
just put a bigger pull together and cooperate more, between governments to understand what are the different strengths, what are the different weaknesses, how we actually manage to rebuild at least part of the global system based on coordination, cooperation, and competition rather than conflict.
Mm-hmm. Yeah, and also I would like to know from this, right, how important will circular economy systems will be because this future energy landscape is going to change.
Mm.
So how do we look at it from
It's almost
your
almost the
angle?
first thing. It's almost the first thing that the Western economies are looking into, right? Given that they have so little mining and
Mm-hmm.
so little refining, they looking at recycling. Let's do recycling. So European Union will throw any funds at you if you come up with a good recycling idea.
I
That
mean,
in
yeah,
itself,
because recently there is new specification guidelines also, right, from Europe
mm,
where they want from 2026 to have the recycled lithium
yeah,
materials in batteries, and going forward, they are also looking at how digital product passports can be used to
hmm
understand the transparency from where it is being
hmm
extracted and where it is being manufactured, and also to understand its overall larger gamut of things of
hmm
sustainability angle, and as well as product how does it look like from supply chain point of view.
yeah,
So yeah, that is a space which is still evolving. It might
yeah.
take some time from to get that attention from all of the manufacturing centers to have the
mm
technology as well as where they come
mm.
in and hop onto this opportunity to build it. But what is your opinion from your experience now that you have seen all these years in this industry?
Yeah, that's true. So Europe is definitely a regulatory juggernaut and definitely at the forefront of these efforts. I looked at it as a sort of investment opportunity, and just the number of failures in that space, especially on lithium side, has been astounding. Here, United States,
Oh, I didn't know
Canada,
that. It's
and so on.
surprising
The,
for
the
me as
the
well.
the technology for lithium recycling is still substandard. I think International Energy Association still
I
sees by 2030 only about 6% or whatever being recycled material. So it's extremely slow. It's faster in some other materials. So e-waste, electronic waste, is a good source. It's a real business. I think
Mhm.
Korea and Singapore, in the US, increasingly, it's not necessarily just the battery materials, but for example, for rare earths, it's one of those, one of those sources of rare earth supply. But just on that, I read some scientific papers on that, is that to make, for example, what's really important, say for wind, right? For wind power, you have direct drive engines. They are full of permanent magnets, sintered permanent magnets, which are suffused with neodymium and dysprosium and praseodymium. That is the most important light rare earths, neodymium, praseodymium. Now, let's say you recycle all of this from some past devices, you still need fresh oxides for the quality of this product. You still need an
Okay.
admixture of mined
Okay.
material. It cannot be based 100% on recycled material for the quality
Resettlement.
of the final.
Uh,
So you still need mining, number one. Number two, it's just things in pure math. If this demand grows exponentially, there's going to be
mm,
always more than what we produced in the past. So we still need some mining. We cannot just recycle everything. And there are two,
mm,
actually, in my book, I explain the two Japanese concepts of cascade recycling and horizontal recycling. I encourage readers to look at this because it's actually interesting what happens to different materials. It's it should be in theory easier for metals or for these elements than for say petrochemicals because you don't actually break down the atomic structure when you recycle. But it depends also on the changing nature of the end demand, whether we can try and maintain the quality of the line at the same level, or whether it was cascade lower to a different use, and maybe volumetrically even a larger use than before. So these approaches are absolutely critical. They
Mhm.
plug the gap in demand. Rare earths is a great example of that, but they don't solve the entire picture. And probably in our lifetime, they won't solve the entire picture. It's probably not going to be able, we're not going to be able to just live off recycling. And the timelines are just as difficult. If I just take the wind, offshore wind power. So all of this massive revolution in wind power in Europe 2 or 3 or 5 years ago, 20 years from now, 25 years from now, to be ready for recycling. And between now and
Mhm.
then, what? Right? So EVs, maybe the first generation will soon start coming in, right, with batteries and so on. And so depends also on legislation. Who's responsible for this recycling? Is it the car makers themselves? What's the
Mhm.
consumer responsibility? But often there will be prices for these materials. Sometimes in the fluctuating market, there will not be very attractive for the thin margins of the recyclers. And then what? Will the governments allow them to go bankrupt, or will they support them because it's such an important part of the economic security just to retain those? That's still, questions for tomorrow.
Yeah, and I believe this is also bitter truth, right? The mining is going to be there, and sufficing the whole of demand with, let's say, alone recycling is gonna be very difficult, and we have to accept the hard truth. So, what role countries like India play in critical minerals ecosystem for this now?
I think the first thing that every country, India is not an exception, should do is just to look again at its legislation, because we have often legislation, whether it's related to mining or disposal of waste, including nuclear, radionuclides, which are sometimes associated with certain minerals. What do you do with this? How do you treat this? How do you handle this product? And then, of course, a question of what are the prices that are necessary for the local business to be incentivized to invest in that. Because if we don't take this sort of bottom feeding Chinese price anymore, which reflects, very elastic Chinese demand, and our demand structure is very different, sometimes very inelastic, then the prices should reflect that. And it's a long process of maybe establishing a price framework within a specific jurisdiction, such as India, protect them with tariffs, and use those tariffs to incentivize downstream industries to move selectively or gradually from that over dependence on Chinese components, and therefore start buying Indian or allied material and so on, and help redevelop that. But really, there's a lot of legislative work here, because India has massive monazite deposits, for example, that could be a source of rare earths, but currently it refines only light rare earths, and that's for fluid catalytic cracking, mostly in
Mm-hmm.
petrochemicals, rather than for new energy. So there is definitely a lot of space to advance legislation and think in terms of the entire system, rather than, okay, this ministry works with this silo, that ministry works with that silo, and so on. That requires a full vision of the supply chain development in long term.
Yeah, and thanks for giving a sharp understanding angle of how can we look at things in terms of moving from legislative and as well as policy aspects, right? So we are at the end of the interview, and I have a last question for you, which would be, what would you say to someone who feels too small to shape anything from your experience?
Who feels too small
To shape anything.
to shape anything?
Hmm.
We never too small. There is no there
Okay.
is there is nobody that's too small. We all have agency. Every human being has agency. Every human being is capable of and capable. We do it every day. We affect our environment, and we interact with
Yeah.
our environment accordingly. And so, uh, ideally, people should be doing something they're passionate about, and then this impact will be larger. I imagine you're
Mm-hmm.
one of those people, so congratulations. But
Yes,
it
thanks.
never underestimate your own potential. I always feel, in India, I've been a couple of times, maybe to a lesser extent, but in the West, people believe that they are so fragile. They're just so, if just something happens, we're all just broken and so on. That underestimates human resilience. We're very resilient. We're very adaptable. If niobium is not an answer to graphite, we'll find another one. So let's be a little more optimistic about it. And even if you read my book, which is about the problem currently, mineral war, therefore the fact that we've been left on the receiving end of someone else's monopolization and weaponization, that's not the reason to despair. We all have agency. We all can affect our environment, and we should be doing it every day.
Yeah, and also I do understand because when I see and look around people around me, the more or one constant quality which I can at least see from India is adaptability. People here change, like every instance, may it be in life or may it be, let's say, out external influences. People here are quite adaptable and they are quick to adjust to things and move on, and maybe they will also bring some other angle making with all the jugats and maybe different angle to it. So
You
we
see,
are at
that's
the
a that's a
end.
that's a huge strength. But let me quote John Henry Newman, who was a British theologist about 100 years ago. He
Mhm.
said that to be human, to live is to change, and to be fully human is to change many times.
Yeah, yeah, that's wise. And we are at the end, Thomas. We have a round rapid fire where I will have four questions for you. You just have
Hmm.
to give one word for each of them,
Hmm. Okay.
and you can make it fun if you're okay with that. So are we ready?
Okay, let's go.
Yeah. So EVs or renewables, bigger mineral demand.
Renewables,
Okay. Mining or recycling, future priority.
mining,
Sustainability in one word for you.
life for many generations to come.
And most misunderstood topic in clean energy.
Urgency.
Fair enough. So that was all. Thank you so much for sharing your insights and valuable knowledge of all like great years of experience what you had worked on in terms of investment, also geopolitics, and then how exactly the process goes on, so on and so forth. I believe along with me, the listener who is listening to has also found great value from this conversation, and thank you so much for that. That's it for today's episode of Get Set Green. I'm your host, Pooja Arve. Thank you for tuning in to the conversations that matter. If this story inspired you, don't keep it to yourself. Share it, subscribe, and join our community of change makers. Together, let's keep purpose meeting planet, one week and one story at a time. Until next time, stay curious, stay foolish, and let's get set to get green.